Hello, guys. Thanks for joining us today. We will be talking about Kafka. It's an essential part of many modern systems. Nowadays, microservices usually communicate through some kind of a queue, and usually the queue of the choice is exactly Kafka. So, in my opinion, every modern programmer should understand how Kafka works and how to interact with it. And that's exactly the topic that Artem will tell us about today. As always, I remind you that you can ask all your questions in the chat, and we will try to cover them all. And without further ado, I'm passing the word to Artem.
Let me introduce myself. My name is Artem Nikitenko. I am a senior Java software engineer. I have been in IT more than 6 years. My primary skill is Java, but I also know a few other programming languages. Also, I have experience with containerized environment, building microservices using Spring Framework, and many different things. In this presentation, I will give you a quick overview of Apache Kafka and how to work with it using Spring Framework. We will reveal what the term transaction means in Apache Kafka. We will solve some problems along the way, and I will show you some places where you can download Kafka. So we have a lot of to get through. Let's get started. First of all, let me remind you what event-driven architecture is. When you want to establish a communication between services, you might apply some intermediate layer, some mediator that will uh, hold a message and forward that message to one or more services. Um, the benefit of this architecture is that those applications do not have to be online all the time, uh, and that allows us to decouple those applications. And it is asynchronous processing, which is especially useful nowadays since users are eager these days. They do not want to wait for too long, and if they do not get a response within a few seconds, they will push a submit button once again and then one more time, and that might lead to certain problems. But this architecture has a downside, like increased complexity, for example, and there's a problem with data consistency, uh, which implies that data might be inconsistent in this particular moment, but within a few seconds, data will be the same across the whole cluster. It might take a few seconds, worst case, a few minutes or even hours. Now, let me show you architecture of Kafka. So Kafka is comprised of topics, and topic consists of partitions, at least one. Topic is like a storage, a queue where you put your messages. And partition is like an array or list in programming language. It has index, which is called offset. And by dividing topic to partitions, we can uh, split processing and uh, scale, distribute our processing. And to achieve fault tolerance, Kafka replicate partitions and here producer sends a message to topic which will be replicated to different brokers to achieve fault tolerance. Um, and there is a term leader, which is uh, a broker that holds main copy of data, and the others are called followers. And there are several types of delivery, like at most once, which implies that messages might be lost during transmission. And at least once, which means messages might be produced more than once and consumed multiple times. And exactly once, that is one write operation and one read operation. Now let me demonstrate Kafka producer in action. So I have chosen Docker container as a way to deploy Kafka just because um, it is a modern approach to deploy your applications. And one of the benefits, you can provide environment variables to adjust some settings. They will be automatically applied to Kafka. I have already started Kafka, and now let me start application. I have prepared uh, REST HTTP server with some endpoints, and let me quickly show you the API. So there are two endpoints where I will send messages, and they will be dispatched to Kafka. Now let me show you configuration. So Spring Framework provides us with a Kafka template, which is a wrapper for underlying Kafka producer from Kafka SDK. And that template requires a producer factory um, that will create the actual producer. And it is capable of creating transactional or non-transactional producer. And to create a transactional producer, you just need to specify this transaction ID prefix. That will be a condition for that factory to create a appropriate producer. Now, let me show you the piece of code where I send a message. So to send a message, you just need to use this send method, and it returns completable future. So it runs asynchronously. Uh, in order to wait for a response, you need to join on this thread, which is a crucial step when you apply a transactional producer. And there are some database calls. I put it here just to uh, add one more integration accept from Kafka. in most scenarios, your application will have a database. So to send a message, I have prepared some cool commands. Idea glitching. All right. Oh, come on. Finally. So I'm going to send this message, which is hello world. And let's see what happens. Copy this cool command. Here we go. Message has been delivered. And now let's look at the logs. There are some API calls like produce request, which is the request for message production, but there are some more like obtaining metadata and identifying which API version to use and some more. And on this diagram, you can see the sequence of API calls that the producer will make when it connects to Kafka for the first time. First of all, we need to define API version, then obtain metadata, and this metadata will be cached on a producer side, and we need to refresh them from time to time. Kafka producer does this automatically in the background. And after we got metadata, we need to get producer ID, which will be used during subsequent calls. And only after that, we are ready to produce a message. And this is like a cold start. We need to make several API calls, but subsequent invocations will be much faster. You just need to produce a message. And now let me show you Kafka Consumer in action. Let me start a consumer. As before, I have prepared REST HTTP server. Let me show you configuration. So here you need to define two bins, consumer factory and listener container factory. And you need to specify listener type, which can be a single or batch. And the difference between them becomes crystal clear when you take a look at message signature. For example, this listener is single and it consumes only one record at a time. But with batch, we get a collection list. But under the hood, Kafka applies batching despite of these settings. There's a fetch request which always operates with batches to reduce network traffic. And to interact with Kafka, there is a Kafka listener annotation, And let me produce a message. But before I do that, let me put a breakpoint here. Same as before, I will send hello world. And we got a message from a messenger topic. During processing, something might go wrong, and it is important to handle errors properly. For that purpose, there is annotation retriable topic, which is based on idea of GLT, that is a special queue where you put your records if they have failed to be processed. And now let me simulate an error. I will send a message that will break consumer. So in this message, I will send a JSON body, and there is consumer field, and it has fail consumption times field. And I will parse this message and use it to throw an error, which is going to be illegal state exception. Right here. So let's do this. Let's copy. And now let me put a breakpoint here and here. And as you can see, we got an error while we processed a record. And now we are going to make two retries. And now you can see we got a new message, and it is coming from a try topic. Now when I resume program, we got into this section, GLT Handler. That is like the last line of defense where you can handle records that have failed, and all retries have been exhausted. And it is usually important to keep this code section sustainable to errors, because default strategy to handle errors from here is to push them back to queue, GLT queue. Now let me show you Kafka Consumer offsets for this group. To copy this command. Here you can see that there's a messenger topic, two topics for retries, and one for DLT. All of them have records. Now let me comment this out, and I will start consumer. And I will send a message that will always lead to error. there's a flag, execute logic bomb, set to true, and it will trigger if statement, and we will throw illegal state exception. Here we go. All right, we got a record from messenger topic. Now we will make our first retry attempt. Now we are making, that is the first retry. Yeah, there's a slight delay because of this back-off strategy. Now we need to wait a little bit because it takes some time. Now we are making our second retry attempt, and we got into this GLT handler. Now I will resume program, and we hit this method again and again. See, I will delete this breakpoint, resume program, and now let's see consumer offsets. Look at this. This GLT topic has more than 1,000 records. And the numbers keep growing. And that is because each time we get into this section, we throw a legal state exception, and the default handling strategy for DLT is to push back this record to DLT so we can reprocess it once again. So we are stuck here. Let me stop this. So be advised that is a default handling strategy for DLT. And there is one more approach to handle errors. Let me show you configuration. There is default error handler, and if you do not specify this common error handler, Spring will create one for you. And if you use both of them, then a triable topic takes precedence. The next thing I want to show you is how you can control the behavior when you want to start your consumer, or you may want to stop it for a little bit, for a while, just for example, to make maintenance work. And by default, this Kafka listener uh, starts consumer after application startup. To change this, you might use Kafka listener endpoint registry, and that registry holds information about all listeners that have been declared in a Spring application context. And it allows us to start, stop, pause, resume our listeners. I have prepared REST API to invoke these methods. Now let me stop all of these consumers. but first of all, I need to uh, start application. All right, it is ready. We got an error, but that is nothing. It is because of our experimentations with DLT. All right, there is several listeners, each one for um, every topic, and we need to stop all of them. I have stopped it first for retry, now for second retries, listener for DLT, and finally our main listener. Now logs are finally silenced. You can see that consumer stopped. Application is working even though. And now let's see offsets for this consumer group. And as you can see, there is no active applications for any of these topics. That is because I stopped them all. Now let's bring back main listener, and I will execute this command again. Now we are back in business. Um, Now let me show you the difference between stopping and pausing. I will grab this cool command. Let me scroll down, and as you can see, consumer sends heartbeats just to let broker know that application is alive. And if we try to look at offsets, Kafka can see that application is active. And now let me produce some messages. Just simple hello world. I will make few of them. All right, I think that is enough. And now let's see offsets. You can see that this topic has a new records, but consumer uh, uh, do not does not read them, and that is because we put it on a pause. To resume processing, we just need to get to make uh, a call, and this will invoke listener registry to resume the processing. And now we got a message. Now let's see offsets. As you can see, all messages have been consumed. All right. Um, Now let me show you how it is works under the hood. Um, so um, when consumer tries to read data from topic, um, uh, it needs to know where to read data from, and so we need to assign a partition. And consumers needs to be united into groups that allows us uh, mm, to apply partition assignment automatically. Um, that is one uh, goal. And the second goal we can achieve here is that it might be beneficial in microservice architecture, um, where you need to scale up your applications to achieve fault tolerance. And you unlikely want all nodes to read the same data simultaneously. So that is where consumer groups come into play. And on this diagram, you can see how everything works under the hood. That is a very long list of interactions. Some of these calls already familiar to you, like API version request, metadata request, and each consumer group needs to have a coordinator to manage the work of that group. Um, After we have found a coordinator, we need to join the group, and that join group request will be actually sent twice, just because the first call is some sort of preparation step. After we join the group, we need to synchronize group state, and that is basically where we get partition assignment. After we get an assignment, we are ready to uh, fetch current offset for this partition, and then we can read data. Um, and after we have processed records, we need to confirm that these data have been processed. And we do that by sending offset commit request. That is a very crucial step. And uh, you can do that in two ways. You can apply after commit, or you can commit offset manually by invoking acknowledge method. And Spring Framework brings us uh, an acknowledgement mode. There are several different types of modes, and some of them allows us to manually trigger this acknowledge method, or Spring might invoke this method for us depending on the mode you have chosen. Now let me uh, show you what options are available to you. So here's the property ACK mode, and by default it is set to batch. And there are some more like record, which means to send commit after processing each record. You can do that manually. Um, and all of these modes are based on counter. There's a counter to track how many records have been processed, or there is different approaches to track how much time has passed during last fetch request, for example. We will do that with time, or you can do both, evaluate the counter and take a look at time interval. There's a term rebalance, which means assigning partitions to group members. And when you add or remove a group member, that is an event to trigger a balance. Um, a balance is not an evil. In fact, that is how Kafka achieves uh, scalability and fault tolerance. But if a balance happens frequently, that might signify that your cluster is unhealthy. Maybe some nodes uh, got down, and others have taken their places. Transaction. Here's how database.
I'm sorry to interrupt. We have some questions. I
Go
think we
ahead.
can answer them now. So
Sure.
the first one was how many partitions do you create? How to select the proper number?
Well, in my case, I just have only one partition, but when you have this uh, kind of structure, that means that despite the number of consumers in the group, there might be only one active consumer, and the other group members will only uh, uh, they will be in idle state. They will serve as a backup. So to make them work, you need at least uh, two partitions. So two partitions, two group members, for example. So you need to have some balance between the number of partitions and the number of uh, group members. But one node might consume several partitions, so you don't have to have the equal number, like two partitions, two consumers. It might be two partitions, only one consumer. So one application can read from both partitions. So you just need to find appropriate uh, number that will serve your needs.
Yeah, so each partition can be read only by one consumer. That's why you need to have at least as many partitions as you will have consumers in your consumer groups. And also, if you have a lot of messages that you put through the Kafka, the network limitations of each Kafka broker can be a case. And well, in that case, you will have to have more partitions, more brokers to spread them over, well, more computing powers to be capable to process all the messages. But yeah, the first and the main advice is to have as many partitions as consumers. Okay. Another question was what is DLT handler? And maybe what is DLT itself?
Well, GLT stands for dead letter topic. You might have heard dead letter queue, but in Kafka we use topic instead of queue, but the idea is the same. That is a place where we put our records that we have failed to process. Um, and GLT Handler is a special method that will be invoked after all tries have exhausted. For example, here this Kafka listener will be invoked for uh, the first time when we consumed a record, and all retries will be executed will execute this consume method. But when all retries um, uh, are exhausted, we have a different approach. We can process uh, records that uh, mm, were unable to recover, like a little bit different. In this case, I just invoke the same method that just add some login statement, but beneath there are some same method invocations, um, but it can be something different. To do something here, for example. I don't know. Uh, it
Yeah, so
depends on your requirements, how you to handle failed records.
yeah, this record failed several times on the usual handler, so it's unreasonable to try to handle it in the usual business way there. I would say it would be a good approach to just log everything and to be able to investigate the root cause of the problem later. Yeah. Okay, I don't see any more questions for now. Guess you can ask them in the chats and we can proceed to transactions.
All right. On this slide, you can see a classic database transaction. And to start a transaction, you just need to begin transaction with some certain isolation level. And then you can do some SQL statements, and at the end you need to invoke commit if you feel like everything is good, or avert these changes if you uh, have made some mistakes. In Kafka world, we do not work with relational tables. We work with topics and partitions. And a transaction in Kafka spans one or more partitions. In this scenario, you can see successful transaction. Producer sends three messages and then commit transaction. And consumer is able to read them all because that is successful transaction, and isolation level is set to read committed. But when transaction has failed, like here on sending last message, we got an error, so we need to abort transaction and mark those records as failed. And these records will not be delivered to consumer uh, because isolation level is set to read committed. However, if isolation level is set to read uncommitted, consumer will still retrieve these dirty records despite the transaction outcome. So transactions and isolation level is like a filtering mechanism in Kafka. It is up to consumer to decide uh, if read those messages or not. Now, let me show you transactions in action. Let me grab appropriate cool command. All right, here's the sample one with hello world message. But before I send this message, let me clean up console. All right, now let's see the logs. Apart from API calls that regular producer makes, there are some more with transactional producer. First of all, transactional producer needs uh, a coordinator, and when we start a transaction, we need to add a partition as a subject of transaction by sending add partitions to text and request. After that, we can produce a message, and when we are ready to commit transaction, we send end text and request. Now let's see the code. And there are no actually any difference between um, uh, transactional and non-transactional message production. You still need to use this send method, and the whole Z class is annotated by transactional annotation, which Kafka template supports. It will use a transaction manager, and when we leave this scope, method scope, it will trigger this transaction manager to commit transaction. And it is it supports only synchronous operation. For example, here we return completable future, and it is not going to work uh, because the way this transactional annotation works, it holds transaction state in a thread local variable, and when you create a new threads, transaction state will not be propagated to new threads. So let me execute this produce async method, and let's see what happens. Let me find appropriate cool command. Here we go. We got 500 error. And now let's see the logs. So here is the error. No transaction is in process. And that is because it does not support multi-threading. You might encounter this problem. It is not a fatal, it's just a warning, but you may face it when you have more than one Kafka template in your application. And uh, basically what it says that we have the same client ID in scope of one JVM. And each Kafka producer needs to have a unique ID. And you can override this by providing a different client ID when you create your Kafka template. How about this? Well, that is actually unrecoverable. We lost the connection to broker, and there is nothing we can do. Only only thing that producer or consumer can do is just try to reconnect, which they will do. That is. Uh, um, Embedded approach inside Kafka SDK. Um, Apart from official Apache website where you can get Kafka, there are some companies that distribute their own builds of Kafka, like Confluent, and they have published their Docker image on Docker Hub, and you can take it from here. That is image that I used in this presentation. And it seems like they do not provide Kubernetes manifest to deploy that image in Kubernetes environment. So you will have to write your own manifest, or you can use Helm chart from Bitnami. They have published it on Artifact Hub. You can take it from here. And there's some other options, like you can use AWS Cloud, and there are um, different providers. So to summarize, um, to speed things up, add partitions and consumers that will help you to distribute the processing across the whole cluster. Um, Remember that errors might always happen, so use retries, but use them wisely. If retries are made badly, they can do more harm than repair. If you do not use retriable topic annotation, Spring will provide you with a default error handler, and I strongly recommend to override uh, default behavior just to uh, uh, mitigate some unexpected retries. And all you have to do is just um, uh, provide this bin in your configuration. Remember that there are different types of semantics, and uh, if a producer user tries, you can deliver messages more than once, and messages might be consumed on the consumer side more than once. So be ready to handle duplicates. And remember about cap theorem. In a distributed world, you can achieve only two out of three things: consistency, availability, or partition fault tolerance. You cannot get them all at once. You need to sacrifice something. Um, that concludes my presentation. Any questions?
Yeah, I forgot to unmute myself. I don't see any questions, so we will be wrapping up. Thanks, Artem, for this talk. Thanks, guys, for joining, and see you next week.
See you.